So welcome to our talk. My colleague Franziska and me, we are both from University of Stuttgart at the Institute for Visualization and Interactive Systems. And we want to talk about the opportunities for visualization cybersecurity. So visualization has a long history, and it's all about accessing information that is written in data in a visual way. And nowadays, the data has become like quite complex, and the data sets we're collecting are very large. So that's why we using visual analytics to come over some of the problems. And first, I want to start with a definition about visual analytics. Visual analytics combines automated analysis techniques with interactive visualizations for an effective understanding, reasoning, and decision-making on the basis of such very large and complex data sets. And frame this, the most important parts are, on the one hand, the automated analysis techniques, and on the other hand, the interactive visualizations, and they work together in somehow an iterative feedback loop, so that we're trying to better our whole visual analytics approach by starting with the data. So we're going to start a mapping and create visualization out of our data, and then use interactions like, for example, zooming and filtering, or showing more details, or transforming the representations. On the one hand, that's like the basic approach how we do visualizations to gain the knowledge out of the data. But on the other hand, we also use automated analysis like machine learning nowadays, where we try to mine out of the data more information, and also creating data models based on our data. And these models can also be used to can also be visualized and then refined later on. And for example, we could adjust parameters, or also understanding the model better, and then getting new knowledge out of it to like use it as an input for our new data collection. If we, for example, figure out that we need some new fields in our data tables, that could be quite of value. So that's like the abstract view on visual analytics. What it means for cybersecurity is also that we still have the goal to understand our data, to make sense out of it, and to make decisions with it. But also we have the challenges that we have, like dirty data that is incomplete, data that is quite difficult to access. And sometimes also we have the problem that we cannot like really define the question what we're looking to be answered by the data. We sometimes also have ad hoc environments and need for specific situations the correct solution. And especially in cybersecurity, we need this contextual understanding of the data. So we need to know how our data works, how it's got collected, and what information is in the data. And that all makes it difficult to automate processes. So we are still not able to automate like all the different processes, also analysis processes. That's why we are creating visualizations to make that better. So, and we also start with data. In cybersecurity, usually we have somehow network data, or endpoint sensor data, or data from other external APIs. And what we try to do with visual analytics is bringing all the different data sources together, and also find patterns between them. And that's why we also doing our pre-processing, our data mining. We try to cluster information. We try to make some classification, filters, and aggregate information, so that we can align the data, that it works well for us to visualize it, and answer the question we're looking for. And for a human, that means that we need somehow an interface as well, and therefore especially dashboards or visual analytic dashboards can be quite of value, because they use multiple views, and there you can like use the pre-processed data and look at it and interact with it. Here I want to show you one example, what we have developed during SAPPAN. We have created the SAPPAN dashboard, and there we can also bring different information together. So for example, we could integrate a guidance by showing playbooks, for example, which a SOC analyst can then be use to look at the different steps which are important. We also have different multiple views on the data. So for example, with endpoint sensor data, where we can look into an host and on the processes running on such an host, but also on the same time can look what happened in the NetFlow data, what happened during the network when we are looking at the host, for example, bringing different multiple views together, or enriching information by like sending some process information to VirusTotal and get an estimation if they are malicious or not. And also we can, in such a framework or in such a dashboard, we can also start collecting the different interactions of such an analyst to use the analysis itself as an possibility to improve processes, to improve collaboration between SOC analysts, reuse it or use it for reporting and accountability. And therefore, we also developed here an provenance capturing tool that captures the interaction an analyst does in our dashboard. And to get more into detail regarding our process tree analysis, one of the visualizations we have as a user, the SOC analyst who's confronted with a lot of alerts, as Misha also mentioned, and therefore we just try to make the data accessible. So we need to pre-process endpoint and sensor data first, reconstruct a hierarchy what was collected by such a sensor, then providing a person an overview, like you can see it here. We have all different activities, and we have with a time bar where you can see when different activities occur. An analyst has the possibility to explore the data, like expanding such processes and the hierarchy on the left side, or hover over such dots which represent different activities of a process to get an idea about what happened on a host machine at this time. And this also leads to analytical provenance data, which we can capture with it. So we can inspect the process information, and we can see like parent-child relationships then. We can see temporal development, and we can also inspect the occurrence of different activities and interact with them. So all in a visual way. And that's about me. I will hand over now to Franziska, and she will talk more about AI for cybersecurity.
Yeah, thank you, Robert. I hope everyone can hear me. At least my window is glowing up. That's always good.
Yes.
Yeah, so now I will briefly talk about AI for cybersecurity and how visualization can figure into that. According to a recent survey by Dasgupta et al., many applications for AI and cybersecurity focus on some kind of detection, like detecting anomalies, malware, a DDoS attack, or an intrusion. So those are the obvious ones. And I think the previous presentations have also shown that this is an interesting area for AI and cybersecurity. But of course, you can also do data analysis and in turn look at data quality using AI. So there is quite a number of ways in which AI can contribute to cybersecurity applications, which makes it quite a good target for increased scrutiny and support with any means available, which includes visualization. And then looking at visualization for AI to kind of bring all the things together, This can be employed to accomplish a variety of objectives, ranging from model debugging during the development phase to communication of findings related to an AI model. In essence, this means that visualization may help to improve or better understand models. It can allow for easier communication, for example, when reporting findings to a supervisor or when training newly hired personnel. And another point, and although this may be more relevant for the future, that's why it's grayed out, it may also help address ethical or legal concerns regarding decisions made by AI or based on its output. And this connects us somewhat to explainable AI and interpretability, which is a topic of interest both to visualization and AI research, and which you may have heard of already. So this has been gaining more and more traction with more and more frameworks and libraries popping up over recent years that let anyone apply newly developed XAI methods to their models and data. There's lots of different methods available, like saliency maps that show regions in an image that the model focuses on for a specific instance. Or in the case of natural language, as you can see at the bottom, you can see which words the model treats as evidence for or against a certain class. So although things like feature visualization in the middle, which can look quite funky and be a little bit hard to interpret. However, as these examples allude to, these libraries are often focused on image or natural language data, which there is a lot of, and require a bit more manual work. So these are more interfaces and libraries and not like complete systems. So you need more work to really allow for thorough analysis for your specific use case. They lack things like connected views and synthesis of different data sources, as well as more sophisticated interaction possibilities. So this means that these methods are quite interesting for visualization that aims to support AI, but may not be easily applicable in any case. For example, when we have data that lacks obvious semantics, like in the case of computer-generated domains. And this brings me to the first of two use cases from SAPPAN that I want to show. This one concerning model analysis for deep learning models. So we've kind of seen a version of this already, though that was an earlier version. So this one combines interpretability with some model debugging capabilities. It's a visual analytics tool that is web-based, making use of D3.js for the visualization and using a Django server with TensorFlow in the backend. In essence, it allows the user to easily analyze training and test data, connect this to model performance, and then also provides an analysis of the model's activations or the activations of the model's nodes for a specific subset of the data, which the user can define interactively using other visualizations. We also provide a decision tree as like a proxy model, sort of a local explainer. And using this explainer together with other techniques like clustering and dimensionality reduction, the user can see how the results from these methods interact to make some sense of the model's behavior, to answer questions like, how does the model go about separating two specific classes? For example, you may have already heard about clever Hans predictors. These predictors come to the right decision, for example, like classifying a picture of a horse as a horse, but base their decision on a wrong feature, like the watermark that is only present for horse pictures. And this illustrates why such questions may be interesting to ask and answer in some way in order to really minimize making decisions for the wrong reasons, basically, and better understanding where you can improve your model and how your model works in the first place. In this example, so the two images, we see 4 clusters. They are represented by different colors in the scatter plot on the left. Our decision tree, shown as an icicle plot on the right, can separate the 2 classes in this data subset quite well using only the feature top-level domain and length. However, it's not quite capable of separating the light purple cluster in the center from all the noise. So the noise are the black circles. And this may indicate that the model has learned a more advanced feature that's not available in our feature set on which we trained the decision tree. So I think the feature set that we started with was quite simple, mostly containing linguistic and maybe some statistical or other features. And this may be an indicator that these are just not enough to explain what the model has learned to distinguish between the different classes in the data. And then, so going beyond the visualizations that most people are familiar with, such a system requires both domain knowledge and some learning of the abstractions and employed visual mappings. As you may have noticed already, there's quite a bit of explaining you have to do in order to even get some idea of what you're even looking at. This makes it something not really suitable for just anyone, but it can improve analysis by bringing together different views of the data, translating features and relations in the data to visual representations, which are most of the time easier to understand, and connecting them via interaction to provide easy access. Okay, then the second use case in SAPPAN, which you've also already heard about, supports sharing, where federated learning is employed to create a better model for all participating parties, for example, to detect malicious domains. And the idea for this one is quite similar to the other one, but basically transferring it to the federated learning case and making sure of, or tailoring it to the peculiarities that this use case has. So this tool aims to let users compare the different models' weight development over the course of training at different levels of detail, because the weights are basically what is shared. For example, the topmost image shows you an overview of weight similarities for all parties per layer. So one spiral is one layer. Each line or each colored line is one party, and the radial lines going from the center to the outer circle are the different training epochs. And we can see that, or rather this indicates how maybe some parties' weights in this particular layer are more similar to another's and how this changes over time. In addition, the user can analyze the model's performance over the training process on a local data set. So here we employ clustering again to find interesting subsets of the data based on the predictions of all participating parties. You can see this in the center right, I think. So there we visualize how these clusters change over time with respect to accuracy, and then also the frequency of the characters in these clusters. So basically, what do the domains in the different clusters look like, and which clusters or subsets of the cluster are similar to each other, in order to get some idea, maybe if things are classified quite differently by different models, why that may be the case, or which parts of the data this affects. So why this particular prototype exposes a lot of data that would usually not be available to all parties in a federated learning scenario. We would still be interested to test how attacks such as poisoning affect the different visualization components that we developed, and whether this could help in any way to detect such attacks like poisoning or something. Okay, then I think we are finished. With this, we conclude our presentation. Hopefully you found something interesting here. And thank you for your attention. If you have any questions, feel free to ask.
Thank you, Franziska and Robert, for the presentation.